the set of real numbers, rational or irrational. In this tutorial, we're going to be talking about the set of numbers known as the real numbers. Now, there is a set called an imaginary number, but we're not going to talk about them today. The set of real numbers is broken up into two separate categories. And although the circles look like they're different sizes, both groups contain the same amount of numbers, an infinite amount. These two groups are known as the irrational and rational groups. And you cannot belong to both groups, you can only belong to one. It's kind of like if you lived on Earth. You would make sense. You're a rational being, you would be a rational number. But if you lived in outer space, like a Martian, that would be crazy. So you would belong to the irrational group. So there are two groups of numbers, rational and irrational. Let's talk about the rational group for a second. In the group of rationals, there are some smaller groups of numbers that are kind of like VIP groups. All of the numbers in these smaller circles are rational, but there's something special about them that sets them apart, and so we give them different names. Let's take a look at their names. If you're a rational number, you might belong to the special integer group, or maybe the super special whole number group, or maybe the extra super special group known as the natural numbers. So first, let's break down how do you get to be a member of the irrational group. Numbers that are irrational are numbers that are crazy. They go on forever and ever and ever, and they never end, and they don't make any sense. And what we mean by that is that they are non-terminating, that means never ending, and they never repeat a pattern. So a non-terminating number might look something like this: 12.753214 ... These three ellipses here means it keeps on going. So because this number keeps on going, and we have no idea what number's coming next, that is an irrational number. There are some pretty famous irrational numbers you might know, like pi. Or maybe you've seen the square root symbol. Not every number with a square root is irrational, but some are. The square root of 2 is irrational because when you compute the square root of 2, it's a decimal that never ends and never repeats. Let's take a look on our calculator. When I type the square root of 2 and press enter, I get 1.414213562, and then it ends because my calculator runs out of space, not because the number is finished. So that is an irrational number. But the square root of 4, when I compute it, doesn't have a decimal at all. It's just 2. And that makes this a rational square root number. So again, if you're an irrational number, you never end and you never repeat. That's a basic definition. The textbook definition is that an irrational number is a number that can not be written as a ratio, that means a fraction, of two integers. And that's the most important part of this definition. It has to state that it cannot be written as a ratio of two integers. Or you can simply say it's a number that never ends and never repeats. As far as rational numbers go, I can take this definition right here and just repeat it, but instead of saying it cannot be written as a ratio of two integers, I'm going to say it can be written as a ratio of two integers. And that's the only difference. So you really only have to memorize one sentence. Be written as a ratio of two integers. And all you have to do is decide whether it's not or whether it is. Now, you'll notice here in the rational number group that I have these extra special phrases. If you're the number 7, you're rational. If you're the number -3, you're rational. If you're the number 1/2, you're rational. If you're the number 0.425, you're rational. If you're the square root of 25, you're rational. If you are 0.333 with a repeating bar, you're rational. Now, some of these rational numbers get invited to be in this very special group known as the integers. And the rule is simple. If you want to belong to the integer club, you cannot be a fraction or a decimal. That's it. Every other number is allowed, but you can't have any denominators and you can't have any decimal parts. So if I look at all these values that we have here, some of these would not be invited to the integer party. And those would be numbers that are fractions, like 1/2, numbers that are decimal, right? Or numbers that repeat and go on forever. They are not invited to the integer party. But 7 is, -3 is, and so is the square root of 25, because the square root of 25 is equal to 5. Now, there's another pretty selective group known as the whole numbers. And not every rational number is a whole number, and not every integer is a whole number, because the whole numbers have a pretty specific requirement. They don't like any negative Nancy's. So all of the integers are invited to the whole number party, but none of them that are negative. So 7 would make it to the whole numbers group, and 5 would make it to the whole numbers group, but -3 would not, because whole numbers like to be positive. And then we have the naturals. They're a super selective group, but they pretty much accept all of the whole numbers as members. Every whole number can be a natural number, except the number 0. Not invited to the natural party, because you can't find 0 anywhere in nature. It's nothing. So natural numbers are numbers you can count, things that you can touch or see. So all of the whole numbers are natural, except the number 0. And that's the breakdown of the groups of numbers. So let's review our understanding again. Irrational numbers never end and never repeat, and rational numbers can be decimals that end or that have a pattern or a repeating bar. Now I want you to focus on this high school definition. An irrational number is a number that cannot be written or expressed as a ratio of two integers. This is a key phrase. It cannot be written as a ratio of two integers. You cannot say the word numbers. You have to say the word integers. So the digits in a decimal would go on forever and ever, and they would never repeat the same pattern. Here are some examples of irrational numbers. Now, the opposite of an irrational number is a rational number, and that means that the number can be written as a ratio or fraction of two integers. Like this, 7/9, which results in a repeating 0.77777. Let's try placing some of these examples in the correct set. How about 4/9? Well, look at it. It's a ratio, and any fraction that has an integer on the top and an integer on the bottom is rational because it's a ratio. How about this one here? -2.13. Does it end? It sure does, There's nothing after that 3. So that's rational. Now how about 13/17? When you put it on your calculator, it looks pretty scary. 13 divided by 17. But isn't that a ratio? Isn't the numerator and denominator integers? So by definition, you're rational because you're a ratio. How about the square root of 10? When we put that on our calculator, we get a pretty wacky decimal. And I can't say for sure what's coming next. So that must mean the square root of 10 is irrational. How about the square root of 9? When I type that in my calculator, I get a perfect whole number, 3. So that means it's rational. How about 0.78 with a repeating bar? Well, this number never ends, but does it repeat? Yes. Therefore, it's rational. How about the absolute value of -3? Well, the absolute value of -3 is +3. That's a whole number, so that's rational. How about this one here? These 3 dots means it goes on forever. Now let's check the second rule. Does it repeat? And the answer is no. It's not the same pattern every time. So this is irrational. How about pi plus 3? Well, 3 is rational, but pi is not. So that makes the whole thing irrational. And last one, 4.32617 ... That looks like it never ends and never repeats. Now let's take a look at some questions I might ask you on a test. Here's a multiple choice question where I'm asking you which number is rational. So you're going to scan down this list and you're looking for anything that can be written as a ratio. That would be number 2. It's the only one that is a ratio of 2 integers, and when computed, 5 divided by 4, we get a decimal that ends. How about this one? Which value is an irrational number? So the square root of 9 is 3. -1/3 is -0.333 repeating. And pi is 3.1415 ... keeps on going. Never ends, never repeats. That's irrational. How about this one? Is this number an integer? Is it rational? Is it irrational? Or is it a whole number? Well, an integer means you can have no decimal point, so that's out. Rational means you can be written as a fraction, and if you go on forever, you have to have the same pattern, which this does not. The pattern is changing, so rational is out. That must mean it's irrational, because a whole number can't have any decimal parts. Of the 3 numbers listed below, which one is irrational? Why is the number you chose irrational? Well, the definition is it's irrational because it cannot be written as a ratio of 2 integers. All you have to do is memorize that phrase. Now we have to pick the right one. So the square root of 4 divided by the square root of 9, which can be split up like this, would be 2/3. Well, that's a ratio. Those are 2 integers, so that one is not irrational. How about the square root of 20? Let's take a look on our calculator. We've got the square root of 20 as our first number, and the square root of 121 as our second number. And 11 is a whole number. So that means our answer is the square root of 20 because it cannot be written as a ratio of 2 integers.